We are still waiting for somebody, or we can start. Aspettiamo o cominciamo? Giovanni? But there is still someone missing. Matteo, Giovanni. Allora, good afternoon, and I have the pleasure to moderate this session. As you know, I'm an art historian, Chiara Franceschini in Munich, and a founding member of SIGN. And in this session, we will assist to the meeting between computer science and paleography, and vice versa, which I think is a very interesting combination with Serena Amirati and Giuseppe Amato. So we have already said that the synergies between the humanities and the sciences are very important also for this association SIGN. And in particular, I think with the artificial intelligence is very important for the humanities. It's a big opportunity to rethink about what is human, actually. So it's a great opportunity, I think, that we have. And it's a pleasure to introduce Serena Amirati, and we move to the field of manuscripts, digitization, artificial intelligence. Serena Amirati is an associate professor of paleography at Roma 3. And she studies ancient, medieval, and modern handwriting then. So handwriting and mechanical writing and automatic writing. It's interesting to hear her perspective about all these problems. And in particular, she has studied bibliology and codicology of the ancient Latin book. So we are very back in the centuries of history, early Middle Ages and late antiquity, etc. In particular, she has taken part in a project about legal texts. And this is what also she's presenting to us today, Medieval Manuscripts Meet Machine Learning, the Experience of In Codice Ratio.
So, hi, good afternoon, everyone. I will be trying to speak with the microphone, moving the remote control. Well, let's see how my multitasking goes so far. Yes. So I'm a classicist by training. I have been studying Latin, Greek, papyri, manuscript. So my familiarity with artificial intelligence is very recent, and it's not part of my traditional Ausbildung. So what I'm going to speak about today is actually my experience, the way I met this technology, and the way I'm dealing with it from an experiential point of view. So what I can do with that. And on the other side, what I've learned so far about this, and what I can teach to my students, which is a main issue in the way I'm using these new technologies in such a, you see, a traditional field. So forgive me if my technological lexicon is not very specific all the time. And yes, let's start. Yes, so, well, it all starts from a curiosity of a colleague of mine from the Department of Engineering in Roma 3, Paolo Merialdo, who wanted ambitiously to do this. The same way we ask to a device, who is the wife of James Bond? You know, James Bond had a wife, yes. Well, at least Google knows. It's this girl here. So we can ask by typing something, as you know, we can ask to a known device like this. And we can also ask different questions, somehow connected with historical issues, like who is the Pope, which is represented in St. Paul outside the wall mosaic? Well, it's this guy, Honorius III, which looks like a little tortoise right here, just worshipping Christ, of course. Yeah, so this is kind of information that we can extract from the web, and I'm sure you know better than me how. You know, he had a successor when he became Pope. Yeah, that's the date. And his successor, who was Innocent III. But there are lots of historical information that we actually do know that exist, but which we do not access in this very easy way, because most of the times they are kept in manuscript like this. This is the specimen of a 13th century manuscript now kept in the Vatican Apostolic Archive, which contains the correspondence of the popes between the age of Honorius III and Innocent III. So what we have here is the copy of the letters that the Pope were actually sending and receiving to all the most notable and not notable people of their ages. So you have Templars, you have kings, you have emperors, you have abbots. And so the ambitious idea of my colleague was, of course, to extract knowledge from this particular manuscript. But the first step we should address was how to make this material accessible. And so the first target was, of course, trying to give a transcription of them. And that's what we focused on. We focused on a very limited group of manuscripts, which is kept in the Vatican Apostolic Archive. The Vatican Apostolic Archive runs 85 kilometers of shelves of documents spanning from the 5th century up to now. 85 kilometers is the length of the Channel of Panama, to give you a ration. So we focused on a very small part of this big consistent repository, which are the Vatican registers I was talking to you about. What is the advantage here? As you can see, they are all written in the same way. So it's the same script that we call the diplomatic chancery script. They all contain a lot of historical information that we only partially know. And they were digitized already by the Vatican Library, which is not, I mean, considering you were talking about fast and slow this morning, but considering the church that is there from a lot of time, they can be very slow, okay? Yes. So we started with this number 12, which contains lots of pages, lots of letters, and which was written by a particular copyist, of course. And so at the very first experience, we wanted to try what is, we wanted to, of course, train a machine learning system for the handwritten text recognition. You know the pros and the cons of this task. First, we started with the idea that the machine learning was needing a lot of training data, examples to teach the system how to accomplish this task. And so we wanted to feed the system with images. The way we decided to do that was twofold. So we had a first approach, which was a crowd-based approach, lots of people, but not experts. And then later on, we had a qualified based approach, relying on professional paleographer. You see advantages and disadvantages of both. Non-expert person, you find everywhere. Expert paleographer, willing to spend 3 months on transcribing very boring pages, not very much. So let's start with the first approach, the so-called crowd-based approach. We decided to involve the students of the high school in Rome in a project which was a sort of orientation program. In Italy, there is a very abominable expression to mark that, which is alternanza scuola-lavoro for the high school students. So they basically helped us in recognizing single letters among the words that were kept in the images that we had. So, I mean, they were not expert in Latin, they were not expert in medieval writing, so we had to keep the task very simple. And what we did was actually like dividing every word into letters and give them a sort of interface in which they could recognize the letter among a chain of letters in a word. Yeah, that was the program that we fed them. I mean, they had to recognize the A among the word fraudabantur by simply marking the strokes. And that's what they were doing. And first, they were doing it in our Department of Engineering premises. Then we designed an app, which we gave them. And they were doing this all the time, especially during school times, of course. When they got bored about something, then they put themselves on this. And they actually fed millions of data, millions of images, which somehow did what we wanted them to do. Yes, 700 students, 26 different schools, different types of schools. So not only people from Liceo Classico, but also from others. And that is the number of images that were processed. Then, of course, we train the artificial neural network with character recognition. Yes. There are some problems when it goes to words that are written in this way and that are written in such different languages. Here you have the word, which is uyushemodi. There are many ways in which you can actually split what you have here, finding, of course, sequences that makes almost no sense, okay? We first over-segment the images, and so the machine gives a different solution. And what we did with this 152 candidate transcription, well, this is an extreme case, of course, but kind of interesting. And then we fed the machine with language knowledge. And so the machine, based on the Latin knowledge she had, was actually able to recognize which was the correct transcription that had to be given. So a corpus of huge Latin documents, and they will start processing the sequences that were somehow that had some resemblance or not. And that's how the process went on the first part. What was the output, the result? We have, in this case, a page of almost 300 words. You have a correct transcription in 62% of cases, 20% with an acceptable degree of error, and something which wasn't processed at all, which are the failures, mainly due to segmentation errors or to some symbol recognition errors. You have to bear in mind that these texts are highly formulaic in the dictate, but very unpredictable because they're full of abbreviations, standards abbreviations, but a lot. And so it's not always easy for the machine to recognize the meaning of the abbreviation. So this was okay, but not enough. So we hired the PhD students who make the boring job for us. Yes. So this approach recently developed was based on the fact that the machine learns at the same time the language and the writing, because we fed it with full high quality transcription from the manuscript we wanted to transcribe entirely. Yes, so basically this. We went on a very sort of precise transcription, which was highlighting somehow even the abbreviations. So the machine could learn even how to give us an acceptable output of this. Of course, this kind of training data is a time-consuming activity. So the PhD was basically obliged to do that. I mean, he was a kind of expert and he was under our authority, so he did it. And but we wanted to give him at least, you know, a nice interface to do that. That's the nicest we could go. So you give the machine a page, the machine segment the lines in a correct way, and then you, expert, go line by line, filling what you see there. That's the transcription which is created. And based on this, the neural network learns how to do the job herself. You can actually, when the machine generates her own transcription, you can correct something, and so to fine-tune the transcription so as the result is actually better, and that's the way the interface goes. And then in 2 hours, the machine, once well-trained, gave us 1,500 pages of transcription, line by line, as you can see. So you can actually have, this is the output we choose just to verify how things were going so far. So 40 pages, and there were very few errors here, less than 8 errors per line out of hundreds of characters. Most lines were perfect, but errors were concentrated in a few lines, and we wanted to detect why this happened. Here you can see, I mean, you have, this is what, this is the correct transcription, and this is what the machine is doing. So sometimes you can see the error is minimal, okay? It's really, I mean, you can almost read the entire line with the proper meaning. Sometimes the problem goes with the fact, I'm sorry, the image is misplaced. Sometimes the error goes with the fact that the page the machine is transcribing contains some abbreviations that were not in the training set. So it doesn't know, and she goes, you know, her way. Or worse, the PhD students didn't transcribe in the same way some abbreviations. So when he has this abbreviation, which is for Cristo, sometimes he uses, you know, the entire, sorry? Oh, yes. Sometimes he uses a way to solve the abbreviations, and sometimes he uses another way. So basically, the training is not consistent. And this is why the machine is actually having errors. So that was the main result we got on this side of evaluating the results we have. The training data must be consistent. So it's like when you tell a child that they doesn't have to eat a cake because the cake contains sugar, but then the child goes and eats drops because, I mean, it's not cake, so I can eat it, but for you, it's sugar as well. So you have to give him the right input, and so it goes with the machine in our case. I'm simply giving here a hint of the importance of good data instead of big data in the way we train this kind of models and according to the task we want to fulfill. And let's see what came after. Let's see what came after this, what we can do with what we've learned so far. Well, first of all, we can use the available training data to work on other documents of similar kind kept in the Vatican or elsewhere. So like the same lexicon, the same text, the same formulae, the same writing, other papal register, for example, that had already been partially edited, can also be used to implement the training data set. But sometimes you have difficulties like this. This is how the original manuscript looks like, and this is how the edition looks like. So you see that there is no alignment. So part of the job now is to find a way to realign the lines of the edition to the manuscript so we can actually use this text as a training data for the next step. And of course, this sort of project led us to some very nice collaborations with other institutions. One is the Archive of the Chamber of the Deputies in Rome. They have lots of documents from the 19th century. We actually discovered that the training machine works surprisingly well, even of documents that are in Italian and this writing. Even this was not the training set. You know, the interface is almost the same, and the results are quite good as well. So that was a good, let's say, collaboration. And then there is, of course, some technology transfer. Some students found, you know, some sort of text recognition can be used in different environments, like, for example, the receipts of a firm, they can be processed like this, or also tax documents, which is which is also very important. The project at the beginning had a sort of echo in the media because, you know, previously the Vatican archive was called the secret archive, so everybody was thinking that we were like deciphering the truth about whatever was kept there. which is not an historical perspective, which is annoying, but gives you a lot of popularity. So that's how things went. Yes, this is my colleague from the Department of Engineers. Yes, but also sensational title, which makes no sense with what we were doing. But some students they founded a startup, MyVirus, which is actually trying to exploit the technology they have been actually find so far. Next collaboration came to the State Archive of Rome, which is another repository of lots of medieval documents. The project, the spin-off of SIGN-VigoniRicerca is now called Matrices. We decided to focus on medieval documents, which comes from the church of St. Cosmas and Damian, which is now near, in Trastevere. Documents there are like 500 and span from the 10th to the 18th century. It's very interesting because this monastery in 13th century became a female one. And so you have a switch in the way the documents were produced, in the lexicon, and so on. What is difficult here is, of course, that documents are irregular in shape and text alignment, but like the Vatican registers, they have the same formulaic text, distribution of the content, and the script is very close to the one we were actually dealing with when we were transcribing the Vatican register. Another issue came in, and it's the fact that most of these documents are different, but written maybe by the same scribe, the same notary who was actually writing down documents over time. So what came from this was the necessity to do some, hand recognition. You can see that the script can vary can be a bit varying, but it's the same person that writes over the years. So the automatic handwriting identification was another branch we are trying to exploit now. We didn't start with the documents I showed you before. We start with easier tasks. One is concerning some very close, among them, minuscule script. These are from the 10th, 8th century. These are from the 14th century, but they're very close. So we tested the machine in order to work with that. This is the way the system works. And again, we have to face a problem, which is the data scarcity. We don't have so many information. We have many digitized manuscripts, but not so many bibliography on which we can work on that. And so the challenge here was to use a few labeled manuscripts and a huge amount on unlabeled ones to work. The self-supervised approach was in 2 phases, which you can read here. There was a neural network, which was learning to represent images by the same copyist. The assumption was that every page was entirely written by the same copyist, and crops from the same page should be represented by similar features. So this step wasn't supervised, but could leverage a huge amount of data. The second part was, of course, another neural network, learning to notice similarities and differences between crops by different copies. This step is the one that is supervised and rely on a very small set of labeled pages. Despite this, the machine was actually able to cluster different script. The case study we had took into consideration 24 manuscripts from the Vatican Apostolic Library. In this case, only 9 manuscripts were labeled, and this is the result. So it's sort of consistent. The way it was actually grouping also different hands, but the same script. So it was actually find some sort of consistency. And then the main issue that we've been addressing a bit also this morning, so the explainability. Can you actually explain what you're looking at? We are trying to apply some techniques to understand why is actually identifying this script, this copyist, and not the other one. And this actually came out by chance, because there was a page of one of the manuscripts the machine was working with, where the machine could find 2 different hands, while the bibliography said it was just 1 hand. And so they showed me that, the engineers showed that to me, and I was like, well, the machine is right. It's two different people here, one in the first column and one in the second. But what is actually the machine doing? Because I have my own method to detect whether it's scribe 1 or scribe 2. What is actually the machine doing? And this is part of the project now. So yes, we decided to find out a way to represent how the machine could work and how the machine could tell us which were the most meaningful part of the images, which was taken into account to say this was copyist 1 and not copyist 2. Now the system is a bit more developed, but the idea is this: green is good, is very good, and the red is not good. So in some cases, you see a pattern of consistency, which is the fact that the space between lines is not considered, but in some other cases, what the machine seems to find is not what you would expect to find as something really discriminating, okay? And this is where the problem with explainability goes, as we were also telling this morning. To sum up a bit what I'm saying so far, well, very simply, me coming from a very traditional training, this was a way to, put myself into the game and to see if I was able to actually being aware of how this technology was working and what this technology could do for me. The other part is that when there is a project like that, it's very important the way you tell it. What I was telling you about the secret archive is an example. So you have to give a good narrative of what you do and a fair narrative of what you're doing and your progress in nothing sensational. This is a low budget university project, which goes with most of volunteering times from PhD students, postdoc, and so on, and of course. It has a very important output also in the way we teach, because there are many ways in which you can teach paleography, but using putting the students in contact with this kind of system gives them the idea that they're not like, learning something which is going to be kept in an ivory castle and not giving them any contact with the technology they use in their own everyday life. Makes the classicist less isolated, I would say. So it's a good point. And then, of course, this can be really an asset for us because the scalability of the process is amazing. So the machine is working, is processing the page in 2 hours. The pages I could process myself in months. And this is not actually the task a paleographer is really doing. So me as a paleographer, I'm not simply deciphering manuscript. I'm an historian of the written culture. So my question comes next the transcription, after the transcription. Transcription is simply a preliminary task. So me doing 1 transcription in 3 months is not like me counting on thousands of pages transcribed in 4 days by this machine. And also the size of my questions and the size of my research can actually expand. And I cannot ignore that there is this big field that is there, that awaits there. I cannot simply turn the face and ignore the fact that I can have these numbers now. And how this is reshaping my research, well, that's a question and also an issue, I would say, because this is not a traditional approach research anymore. And of course, this happens only if, paleographers like me and diplomatists are the historians of the written documents, are in the loop, in the process. So we cannot develop such technology, such useful technology, if we don't if we don't ask the right questions. So for me, there is no point in transcribing the manuscript of the Vatican Library because they contain texts that are already known and edited and published. I want to know what is written in the documents, which are not edited in the same way. This is one of the things. The other thing is that there are scripts that are very difficult and scripts that are not. And so I can reshape my questions according to the difficulty of the reading. And then there is the issue of explainability. So I need a system that I can trust somehow. even if this is not, you know, a medical diagnosis, even this is not a 1 billion grant to somebody, still it's my science. And I want my science to be somehow, you know, verifiable in the same way the others are. So even if it's about detecting one copyist or another, this is an issue that matters to me. And so I really want the machine to be able to explain what she is doing. And actually, this can actually help me fine-tuning her, but also her fine-tuning me, because maybe she's spotting out relevant things that I'm not thinking about when I'm doing this very intuitive process of recognizes different handwriting. And I think that, yes, that's it. Thank you very much for your attention.
Thank you very much. And we have 10 minutes or something like that for discussion. Is there any question? Yes.
Yeah, fascinating talk. Thank you for that. So you mentioned that, yes, what you presented is just the first part. I mean, it's more like a tool to prepare yourself to do your own research, right? And so I wonder, is the document or the scale of the documents you're talking about, I mean, 86 kilometers and so forth, would it be in the end large enough to use this as a basis for training a large language model, so that you would have an integrated model of all the documents, or vast part of the documents, so that then you could reorient your kind of research in a way that you could pose questions, like Anna Maria presented this morning, right? I mean, that you kind of try to use these large language models in an interactive way to interrogate what is the content and of these documents, or the body of documents, without having to read each and every single line in each of those documents.
Yes, that's exactly what I aim at. So one part is the extracting the historical information. So the next part would be, of course, semantic annotation of what we have. But the first step was to make these things available in this way. But also making these things available brought us to other research issues that we didn't consider at the beginning, like the copyist, like the type of writing, like the fact that this machine trained on medieval writing can work on a contemporary writing as well. So, and can I just say something sort of political? I work for a public university in Italy with low budget, but this gave us this sort of freedom, you know, like we could experiment in different branches as long as we could pay the PhD students at least, you know. But still, the idea was, let's see where this takes us on an engineering perspective, on the paleographer perspective, and so on. Now I have lots of pages which are transcribed, and already with the transcribed pages, this has an enormous value, because I can see if the scribes is consistent over the pages in the way he writes, which is an historical issue for me, which is very important. So at this scale is already something big, but of course, the next thing is how bigger can this grow? And okay, I have to be honest, of course, we are not the only one doing this. There are even more sophisticated systems which have been developed. There is one which is very popular, which is called Transcribus, where you have, but Transcribus works with, I mean, Transcribus is not for free. This one is open source so far. And the other thing is that Transcribus aims at the transcription. Okay, I want to see what all the process, and I want to see what comes next. And so that's, I think I have replied. Yeah.
Sorry. I might have missed some details. So anyway, very interesting talk. I liked it very much. 2 questions. You said you are using as training data 40 pages transcribed manually. And you train a neural network by using these 40 pages. But are you using a pre-trained network, or you train from scratch? From scratch. Okay, so is it possible that probably, I mean, the errors that the errors that you saw might also depend from the fact that the training data is not much large.
Well, the training data is not much large, but with this small amount of data, the result is impressive anyway. So I think that for this kind of training, you can keep this ratio, okay? And then once the machine has transcribed and you have fine-tuned the transcription, then you can use the 500, the 1500 pages, you know, as a pure good data. You know, it's a pure good data on another scale, of course. So, yes. Yes, the scarcity was one issue, of course, but it was something intentional. Like, let's see what we can do with this, because I mean, this took like 1 month of human work, okay, which is a lot. In terms of technology, I guess for us it's nothing. It's like you can stare at a manuscript years, but for you know, if you want to be efficient, this is not the case, okay? So, and then we saw that the main problems came from the fact that the transcription was not consistent. So the potentiality is bigger. Yes, exactly. But yes, but in this case, very detectable noises. So yeah.
Because yes. Just on that point, because from what I understood, the difference is really between your first try and the second one. I mean, if it were possible to do this sort of citizen science approach that you call everyone to help, but this is not the case because you need.
We tried. The first one was some sort satisfying. Was very satisfying from the perspective of involving high school students, because it was a way. Yes. Yes, and can I add something? In the first interface we had was simply with we didn't have the word, we just had the letter. And they couldn't detect the letter without the word, which goes with the way we read. I mean, we can detect a letter within a word, but we cannot recognize an isolated grapheme if there is not a context. No, we do not. Yes, we do not computate. We read synoptically from the ends of the word to the center, and that's what actually they were doing. So the A was there because it was after a D and before a D and so on. Yes. The second way worked much better.
I think it's a good, a very interesting project, but I'm not really sure that starting from scratch, having transcribers was a good choice, because most of the things that you've done are already there, and you just paid $18, is not bad, for transcribing or having a new model for 500 pages. So maybe what I'm saying is that, especially in digital humanities, I am in digital humanities since 30 years, and I've seen a lot of projects that starting from scratch, what has been already done by other people, and then you lose time, money, and then probably most of these projects simply dies, and I even not remember. Once there is a sort of big infrastructural thing, I don't know people from transcriber, I'm not involved, so I'm not advocating that, but the idea is that, and okay, they are selling, but I mean, you can have also good deals if you have a big project and you can take agreement. So starting from there, because they have the models for the aligning, well, the finding the lines, and it works, and you can, and they, I mean, I've seen in transcribable things that were really incredible, multiple columns with, and you have the model already there. You can use the model if this fits to your needs, or you can, starting from that model, retrain a new model. And the same goes for writing. Then you could build on that for doing the other stuff that you want to do, that is using the text extracted from these documents to gain historical knowledge. So I'm not really sure that this is a right way to, this is something that is very typical for humanists. Every humanist just start from his own little piece of knowledge and want to build from scratch everything. And I think if we don't change also this way of thinking, we will never have a momentum in this kind of research. It's not polemical, just something that I feel ill for myself, and because I've learned a lot in my 30 years in digital humanities.
Well, I take your point of view, which is correct in the sense that I mean, we know the people from Transcribus, we are in contact with them, and we actually bought a premium account to do our stuff on their site. And I have to say the results is not as accurate as we expected, the way we did our own, okay? So I'm not saying, I mean, I have seen how they segment even languages like Arabic, which has a word in every different corner of the pages and so on. So I feel like there is going to be a sort of merging or convergence on that.
Stop the second part. Why don't you try to get in contact with them and say, okay, we have seen that your models doesn't work for doing that, so we can maybe find a way to interact and add something that your model doesn't have. I think they use convolutional network, so it's not such a mysterious technology, something we know since 30 years as well. So, but maybe the way in which they use it is not good for your document. So getting together and try to, I mean, make unify the efforts could help. So.
It's true, and this is actually part of the project. Like one of the engineers working for us is writing an article about comparing what we do with what Transcribus can do for us and what Transcribus has done so far. About the fact that the humanists work like islands, not connecting. Let me say something. This project started because an engineer wanted to transcribe the entire Vatican library without knowing it was pointless. So. I mean that was I mean, and I'm not blaming the fact that it was actually, I mean, it was so ambitious that I was like, well, come on, but it's pointless because we already have those texts. We need other texts to do that. So let me say that maybe this is I mean, it's a wrong assumption, but it's also an assumption which is cultural in the way people from the STEM as somehow, I would say, I mean, we have been separated for a very long time, for many times of for many collaboration. We are not used to think this big. You know, like I am starting thinking this big after this, and we only had like 150K in 4 years, okay? And this is already huge for me, coming from a Department of Humanities in Italy. I don't want to like doing the part of, you know, the poor humanist, you know, like the one which is in Big Bang.
But also the problem of the error, of diminishing the level of errors for a philologist, a paleographist is very important. I mean, the precision it's something, it's all based about that transmission of texts. It's, even one error, it's a problem because you do something, you introduce something in a tradition that is not, so it's important to refine, I think, as an experiment of dialogue with the machine, to find a way of reducing more, even if a small set of documents, because it would be impossible probably to do it for the entire.
And I think that the big project, they don't have any interest in this so precise thing. For me, a per instead of a pro changes everything. I know it's said like this seems sort of snobbish, you know, like, oh, wow. Yes. Yes, for some things, yes. Then I see the point.
So I have a small comment, because this is, I think, a German-Italian meeting. So our colleagues in Berlin at BIFOD and also the Max Planck Institute for the History of Science, they are also doing very interesting work in this direction. So they're using explainable AI to find some relations, similarities, and explain the similarities between historical, to see how like ideas in the sciences have developed over time. I think that
Humanists are more interested in the contents of letters, documents, etc. But a paleographer is also interested in the form of writing. So it's different. It's not just the content that you can, it's also the form. Exactly. So it's different.
No, but I think what they also look at is this graphics. So if you have like this astronomy books, so they have some graphics and they want to understand whether some people have copied like images from other books and they want to see like which ideas occurred where and which one were copied from other areas. And I think this is what they do. And the guy from the Max Planck Institute is even, I think, an Italian researcher. So maybe I can give you a link later on if you're interested.
Yeah, with the extended reality project, I think Giuseppe Amato is research director of the CNR ISTI in Pisa and leads the Artificial Intelligence for Multimedia and Humanities laboratory there. And he has a PhD from Dortmund, I have read, so that's an important connection with Germany. And you will present about your big project, but it's interesting that you also work, I think, on reduce mobility capacities and the way in which extended reality can help that. So, and also collaboration with the humanities you have mentioned before. So thank you very much. And we look forward to you.
Thanks a lot for the introduction. And also thanks to the organizer for inviting me to this very interesting meeting. I'm going to tell you about this SIGN-XR project. SIGN-XR stands for Social and Human-Centered Extended Reality. It is a project funded by the European Commission. It started last December, so we are within the first year of activity. So I'm going to tell you about the direction, the research direction that we are following in this project and the result that we are supposed to reach. Okay, let me just put you in context, which is the vision that we have in SIGN. So extended reality builds on top of augmented and mixed reality, which in turn builds on top of virtual reality. Virtual reality, I think most of us let's say, quite confident on what virtual reality is. I mean, you have a 3D virtual environment, which you see through some visors, through your computer screen. When you play video games, for instance, you are basically using virtual reality. So you are immersed in a virtual world, but you are isolated from the real world. So you don't touch the physical world. You are just in a virtual world. With augmented and mixed reality, you go a step forward. The two worlds are fused. You see virtual objects overlaid on top of the physical world by using smart glasses, for instance, or tools like this. And in mixed reality, you can also interact. While you are in physical world, you can interact with the virtual elements. So you can take virtual objects seen through the physical world and move, touch, enlarge, etc., etc. Well, extended reality, at least within the SIGN-XR vision, goes still a step beyond. Users can feel, can touch virtual objects. So the, let's say, ultimate idea is to have people not distinguishing between the physical world or the virtual world. I can take a physical bottle and I can take a virtual glass and have the same feeling, have the illusion of handling real objects, physical objects. This is the ultimate dream. Still a long way to reach this, but this is the objective. Okay, so in just 2 sentences, the objective of the project is to first overcome current limitation for extended reality, and I gave you some idea of what might be the current limitation for this. So in such a way that the integration, the fusing of virtual and physical and virtual world is made in a convincing way. You do not distinguish the two worlds. And the virtual world should be a kind of augmenting the physical world in a non-perceivable way. So you should not distinguish between the two worlds. This is the ultimate idea. What we did is to identify which are the current limitations, and we have a number of possible solutions for such limitations. So limitation is that poor scalability and high cost. Suppose that you want to implement an extended reality application in this room. You have to digitize this room to create 3D models of every single object in this room and to move it to the virtual world as well. It costs a lot. So once you do it in this room and you want to move in a different room, in a different environment, you want to go outside, you have to start from scratch. You cannot reuse anything. You have to redigitize everything. So we're trying to address this problem using artificial intelligence to incrementally learn, incrementally build the virtual world from the visual world and build incrementally libraries of objects that you can reuse. Once you have the digital twin of this bottle, you can reuse in the future if you see the same bottle later on, etc., etc. And in order to address this problem, we are doing research in various directions, ranging from creating on the fly virtual 3D models of the physical world while living in the visual world and using, for instance, semantic priors. So reusing library of objects or library of elements that you already have. Solutions for mass scale creation of avatars. Remember that, I mean, when you have a virtual world, you also have persons in the virtual world, and you want to build avatars of the person living in the virtual worlds, but you had to do that. So we are also investigating solutions for mass scale production of avatars of people. Second limitation that we identified and we're trying to address is to, let's say, address the barrier between the two worlds. You have the physical world, which is the world we are used to interact with, and the visual world. They should be integrated in a convincing way. So you should not, as I said at the beginning, you should not distinguish between the two when you are in this world. So virtual elements should have exactly the same properties of physical elements in terms of consistency, weight, feel, temperature, etc., etc. And in order to address this, we are investigating solutions to create digital twins, realistic digital twins of physical objects. And one direction that we are investigating is to identify, segment objects from the visual world and create automatically relationships with the corresponding virtual elements. So a physical bottle connected to the corresponding virtual objects in the visual world. So they live together, they are connected one to the other automatically. And we are also investigating solutions for digitizing non-visual properties of objects. I mean, typically when you create a digital model of a bottle, you just focus on the appearance, on the, say, visual appearance of the objects, but the bottle has physical properties. It has water inside, it has a weight, it is made of glass, etc., etc. And we are developing solutions for also acquiring physical properties of objects while acquiring the visual appearance of the objects. We are developing these passive grippers equipped with pressure sensors, which are used to manipulate the objects while acquiring the visual properties. So this gripper is put in a chamber and it moves the objects, but while moving the objects, it feels the weight changes, for instance, by using the sensors. But at the same time, with the cameras that you have in the box, you acquire the visual properties. So you can connect the position of the objects, the 3D model, and the mass distribution of the object itself. Third issue that we are addressing in the project is to provide users of extended reality with a natural way of interacting with the two worlds. We are used to interact with the physical world. I can take this bottle, I can ask people to do something, etc., etc. I need some, say, similar way of naturally interacting with the virtual part of the extended reality. And in this direction, we are developing various solutions, ranging from developing wearable haptic interfaces, multi-sensory feedback with 3D objects, and gaze and gesture based interaction relying on artificial intelligence. More specifically, we are working on developing haptic devices in order, for instance, to have the impression of the sensation of touching something. I think most of the things that you say, tell us in the morning are very useful also in this context, so we should try to talk about this. So here the challenge is to, let's say, miniaturizing the devices. I mean, you don't want to be constrained by heavy equipment attached to your body. I mean, you want to wear a glove, no more than a glove, and have this kind of functionalities. We are working on thermal feedback. When you touch some object, a lot of feeling about the object. Typically, you recognize the object that you are touching, even if you don't see the object, because of the temperature transfer from the object to your hand. I mean, glass transfer temperature in a different way from rubber, different way from wood or metal. So in order to provide people with a feeling of touching something made of glass, you had to transfer the temperature in a different way than if the visual object is made of wood. So we are working on a thermal feedback system to provide users with this illusion of touching real objects, even if they are visual objects. We are working on EMG decoding. EMG, it is a scaling acronym, but the idea is to intercept the signals going from the brain to the muscles. So when you move your hand, some signals go from the brain to the muscle that move your hand, but you can intercept this information and produce the same result in the virtual world. So you move your real hand, but you also move the virtual hand by intercepting the sensors. And we are using this also to help people with disability. I mean, suppose a person doesn't have a hand, but the brain can think about moving the hand. So the physical hand, it is not there, but he can move a virtual hand. Person is blocked in bed, he cannot walk, but a person can have the illusion of walking virtually by using this EMG decoding. I think I was talking with some of you yesterday or even today about the fact that we are multimodal. We do not use one sense at a time. We don't just see, we don't just hear, we don't just touch. We use all our senses simultaneously. But the same happens when we act. We speak, I use gestures to emphasize what I'm saying, etc., etc. Let's do something similar also when we interact with the smart device, when you want to interact with the visual world. So using, for instance, at the same time, gaze, I move my eyes and I give some signals to people. Gesture, of course, and also voice. I mean, we can mix together several ways of providing the system with input about what we want to do. Okay. Almost at the last challenge that we're going to address. I mean, I don't know how many of you have tried to use some smart glasses, for instance. You or someone else, I don't remember who showed the Okay, he was, Antonio, I think it was a picture of a HoloLens, okay, which is considered nowadays is considered to be state of the art for smart device, wearable smart glasses. But okay, they are heavy, and computing power is not so good. So you, for instance, you do not reach photorealistic rendering by using the computing power of the smart glasses themselves. So so you feel the difference between the real world and the visual world, also because they look differently. We have very high resolution in the physical world. We have low resolution. We have good color, realistic colors. We have, let's say, fake colors in the individual world. So we're trying also to address these issues by working on techniques for improving render quality at the device level. The idea is to be able to produce photorealistic rendering also on low computing power device. And by the way, there is a German company working in the project, which is working on those solutions. The company is called All Light. We are also working on improving the quality of the 3D models in case they have problems and they can, say, reduce the photorealistic quality. And we are using artificial intelligence to, for instance, fill errors, holes, or say imperfections in the imprecisions in the 3D models. And here you can see some example of improving quality of 3D models automatically generated. Okay, this was the most technical part, the, let's say, main challenges that we are currently addressing, but we would like to demonstrate the results. Hopefully we will be able to solve most of the problems that I mentioned, and we would like to demonstrate those results in 3 real-life pilots related to social and human-centered applications. The first pilot is using extended reality for rehabilitation. Second pilot is using extended reality and is testing, let's say, or let's say verifying how good it is. Extended reality to improve safety in work environment. And last but not least is using extended reality to help people with some disabilities. For instance, people that cannot walk, or people who are missing an arm. Or okay, in the first case, the idea is just to give you an idea of the vision here. Is suppose that someone has to do rehabilitation. Typically, the person that has to do rehabilitation has to go to the hospital and see the doctor or the physiotherapist that helps him in or correcting him in doing the exercise. But probably you can do it from home by using extended reality. The doctor stays in the hospital, you are at home, and you have the feeling that you are in the same room, even if you are not in the same room. The doctor can touch you and correct the movement. You can have immediate feedback about the correctness of your exercise by analyzing how you're doing the movements, etc., etc. So this is the first pilot. Second pilot is, I was saying, about improving safety in work environment. The idea here is double. At the same time, using extended reality for training people and concerning the safety procedures in the work environment, but also provide workers with an augmented way of receiving alarms about possible threats in the work environment. There is something coming from your right. I mean, you are in a noisy environment, so you might not notice that some heavy weight is coming from your right, and you get an alarm by using extended reality, or some feedback sensor tells you, okay, move, something is falling down. And last but not least is help people with some disabilities. For instance, people that cannot move, people blocked in bed. And here the dream is I'll tell you the story about this. This pilot. The dream is to allow a person blocked in bed to walk in the park with his friend or her friends, and vice versa. I mean, their friend are working with him, even if he is blocked in bed. He has the feeling of walking with a friend in a park while blocked in bed. This is the last pilot, and this is the dream team. This is the consortium working in this project. And okay, red ones are Italians and green ones are German partners. So there is a, let's say, fairly good contribution from both sides. The German ones are Alllight, the one working on the improvement of rendering quality in smart devices. Into is a software development company. He's supposed to integrate the various components that are going to be developed, and OAC stands for Outdoor Against Cancer. They are supposed to host one of the pilot I told you about, I mean, specifically for rehabilitation after cancer surgery. Okay, the project has started in December, so we are at month 8. Still long way to go. The project is supposed to last 36 months. So stay tuned. Hope to be able to show you some amazing things in a few months. If you have any questions, I might be happy to answer.
Can you tell me more about the haptic devices that you use? What are the capabilities? Because my understanding is that building good haptic devices that can transfer a lot of information is actually really hard.
Yeah, actually, we have 2 partners working on haptic devices, and it is not CNR, but I can tell you what they're supposed to do. The 2 partners working on haptic devices are Scuola Sant'Anna from Italy and EPFL from Switzerland. And they are following various directions. One is actually building some actuators and sensors that are able to both detect stretching of the skin, but also produce stretching of the skin. So you have the feeling that someone is touching you. But the same sensor is able to guess how you're moving your hand by analyzing how the skin is stretched. Second technique is the thermal feedback I was mentioning before. So there are some thermal actuators attached to your finger, if you have your finger, or to your arm. And when you touch something, depending on the type of material the object is made of, you have a different gradient of transfer of temperature from the device to your body. And last, this EMG decoding, so getting signals directly from the brain, on the path from the brain to the muscles, in order to receive this information, but also in order to analyze this information, but also inject this information from outside. So giving signal generated artificially. I don't know if this was the question you
Just more on the question of whether you can sense forces or vibration, not sense, but introduce forces, vibration, because there are many of the sensors, many of the haptic devices are basically just flat surfaces where you can change the normal force and density.
Let me see if I have a picture on it. I'm not sure. Okay. No, there is not the one on. I mean, you have this kind of devices which give you the impression of pressure on your finger. And I don't have a picture. I think no, it is not here. You have this kind of bracelet that you can put on your arm to both detect the stretching of the skin, but also produce movement on your skin. Okay, right.
Is there any?
Yeah, but curiosity that is out of science fiction. Do you think that this stuff is quite interesting, but probably they will never work for the mass public because this kind of stuff, even if you miniaturize them, would be so complex to have to build, to buy, and to sell because it would cost a lot of money for people to wear. So maybe the future of this kind of research will be in the direct interface between the brain and the system in one, and that will happen maybe in 100, 200 years, I don't know. But because I don't see really people wearing all this stuff for doing normal things like, I don't know, going around see monuments, or maybe for working environment for some specific activities they may really work. That's why also probably made us kind of given up to the great picture of the project also. So they said a couple of months ago.
I will say never say never. No, in 2009, I was running a project where we wanted to use mobile devices to recognize things, to search Google. I mean, instead of typing keywords to search for Google, you just point your mobile phone and you retrieve information. It was 2009, so 14 years ago, and people said, okay, you're crazy. I mean, mobile phone now are very small, and you can feel in your pocket. You have flat internet which you can use. People say, okay, you're crazy. It will never work. You cannot use it. But now, I mean, it is given for granted in many applications. I mean, using visual recognition to trigger actions. I think here we are more or less in the same direction. It is possible to have maybe in 20 years we will have something like in the Matrix movie where you have something connected directly to your brain. I don't know. In 100 years, I don't know. But what I will say, I was saying that nowadays the HoloLens are very heavy and very uncomfortable to be worn. But probably in some years, this is the smart glass that we're going to use. So something that we already have. But probably we will have sensors in our clothes. I mean, you will have sensor on your shirt. Give us sensations like the complexity of sensation. Probably you can get thermal. You can get thermal feedback. You can also have counter reaction. I think most of them will be. They are not yet, but they may. I mean, I was talking about stretching. You might have that your shirt stretch your arm like someone is grasping your arm. Why not? Or he can detect how you are moving your arm using sensors in the clothes. Still a long way to go, but who knows? I agree with you. Nowadays, I mean, this is probably very uncomfortable. I mean, HoloLens are very uncomfortable nowadays, but smartphones were uncomfortable 10 or 15 years ago. Now you put them in your pocket and you use them.
That's maybe complete physical thing that you have in your body, and then reveal all the complex interaction of your body. Many different things, and on something that show you something in your eyes. You touch me from behind, I feel that you're touching. I need something that gives me the same sensation, or an approximation of the real sensation will be kind of much harder than a lightweight.
Yeah, okay.
Maybe we'll see a mix of what you're saying and what you're doing. I mean, as we've seen during the morning, we are understanding the brain functioning. So we may have a mixed technology that perceive directly from your brain and maybe do things from your body. So maybe both technologies will be used. Yeah, sure.
Just as a last example, I'm wearing this smartwatch which constantly monitor my heart rate. It has sensors. I mean, probably I will wear in 10 years. I will wear a smartwatch which does much more than just monitoring my heart rate. But he will perform EMG decoding directly from the smartwatch. You don't need to put electrodes in my skin to do the same. Who knows?
Yet another question.
Just out of curiosity, this is also very fascinating, the way that some objects can be functionally improved, but remains the same. You know, like when you speak about wearability, for example, this is what strikes me. You know, like maybe in 10 years we will still have a watch doing. So how about thinking of like in these terms of concentrating our design, which is already somehow familiar, but which is more potentially developed for the functions you are exploiting?
Yeah, probably the direction will be the following: something that we already use will be enhanced. I mean, watch, glasses.
Let me say, prodromo mea, like a book, you know, like a book, yes.
Yeah. No, but probably a couple of months ago there was an advertisement on TV made simultaneously by Meta and Ray-Ban, advertising some Ray-Ban glasses with a camera in it. I mean, that model has just a camera which is connected to your mobile phone, so you can take pictures and you can take movies with your glasses, and it goes to your mobile phone. This is already a step beyond what we are used, but probably in the future, I mean, there will not be just a camera here. You might have projectors that go, like in the HoloLens, that go in your retina, and you see the virtual world on top of the physical world through your, let's say, almost normal glasses. Yeah.
Yeah, thank you very much. I have a curiosity as well. We were talking about multimodality and the senses that we also mentioned this morning that are quite difficult now to replicate: taste and smell, which are actually very important for us. What about these? What's the future of these? What if you?
Yeah, actually, I think it was Antonio talking about this smell and taste. Okay, it is challenging. It is not, in fact, part of this, but currently we are not addressing taste and smell, but touch and temperature. But, you know, in order to have a full compatible virtual world to the physical world, also taste and smell should be considered. Yep, agree with you.
Thank you very much. I think we have reached the coffee pause. Yes, that's 4:30. Thank you, Giuseppe. And we gather here again at 5 o'clock for our last session. Mm-hmm. Grazie, Francesca.
1, 2, 3, 1, 2, 3. Vado? 1, 2, 3, 1, 2, 3. Basta. Quindi non c'è bisogno di parlare così vicino. È solo per il microfono in sala. Okay. Cioè, ovviamente da lontano non ci si sente nel monitor. Da vicino è solo per il microfono in sala. Per il... Anche se però sul... Ok. Ottimo, grazie del consiglio. Quindi più tenerlo direzionato, no? Okay. Lo diciamo agli speakers. There is no need. Du musst nicht einfach so halten. Es reicht auch so und auch aus dieser Abstand, weil es geht um so. Dass wir so auch hören, ist nur diese Feedback bei diesen Lautsprechern. So dass, wenn du der Einzige bist, der spricht, ist genug, dass du hier bist. So, du bist frei. Nur, denk mal nicht, das zu sprechen, aber immer in diese Richtung. Okay. Super. Very good. How do you start? Tricks und Tipps und hast du Geld gemacht, aber nur ein Tipps zugeschlossen. Nach vorne kommen, jetzt in Unternehmen. Es gibt in Deutschland viele Mittelstand, die nicht an die größte Familie sind. Ja. Und wenn die Kinder nicht Sport haben, dann Sport. Sag an Francesca. Francesca. Che... Ah, Anna Maria, vai via. Ciao, ti saluto. Buon viaggio, buon ritorno. Allora, il fatto che ci sentiamo qua in sala non ha niente a che fare col fatto che in Zoom ci possano sentire. Quindi da Zoom, anche da questa distanza, dice il nostro tecnico, ci sento.
Era la sua collega che mi aveva detto che se era spento il microfono non si sentiva nulla. Ah, ok.
Perché ad esempio parlando così, la gente in Zoom sente, anche se il loudspeaker non riverbera. Ovviamente se io parlo qua dentro si amplifica di molto.
Ok.
Li sentite dagli stessi microfoni.
Ah sì, perché penso che... Non viene di lì?
Io mi fido di quello che mi dice.
Da questi? Sì.
Invece ho visto che tu sei stato premiato a Genova a Palazzo Ducale.
Sì.
La direttrice di Palazzo Ducale è una ex collega. E non abbiamo lavorato in contemporanea perché è andata via prima che io arrivassi, è moglie del conservatore del nostro patrimonio artistico, quindi la conosco. Infatti se vedi queste piccole guide che vi ho portato non sono nuovissime, le ha scritte anche lei.
E questo patrimonio artistico quando si può visitare?
Avete visto le cose più importanti, no? I quadri, poi ci sono alcune altre cose che sono in deposito, sia a causa dei lavori, sia perché non si riesce a esporre tutto, ma diciamo sono principalmente quadri e altre opere d'arte, e poi c'è la biblioteca storica, ci sono delle copie originali di manoscritti, e quindi c'è un archivio.
Il rettore del Poli conosce Villa Vigoni?
Io penso sì, cioè io non conosco lui personalmente.
Dovremmo portarlo qua. Possiamo organizzare qua questo è introdotto un'idea incredibile. Un merging delle due option rettori in conferenza. In Italia c'è la COI, Conferenza dei Rettori Universitari Italiani. In Germania c'è la...
Dovrei informarmi se magari ci sia già stato qui, che non è detto che non ci sia già stato.
Non lo so, ma passa questa informazione. I rettori ogni 4 anni cambiano, quindi se c'è stata non negli ultimi 4 anni...
Allora, negli ultimi 4 anni sicuramente no, perché da quando ci sono io non c'è stata.
Perché
Magari
i
in passato.
rettori italiani e tedeschi sono un organo politicamente molto potente e un dialogo bilaterale in cui li si invitano, poi verranno alla fine 10, l'Italia 10. È una cosa di altissimo livello, i soldini per quel livello i ministeri li trovano e secondo me, specie per la tecnologia, nel momento in cui l'Italia naviga nel PNRR e tra 3 anni non ci sarà più, fare delle sinergie con la Germania sarà fondamentale. Quindi se vi serve un aiuto lì posso... Io ne conosco un po' di rettori.
Proverò a chiedere la questione poi
Finanziamento. Tanto le conferenze dei rettori sono
ma non
sparecchie.
stavo parlando di quello in realtà, cioè c'è tutta una questione poi diciamo di complessità diplomatica, no? Che è da un lato fa parte del nostro lavoro, dall'altro bisogna considerare tempo, ci sono
Però si può chiamare la prima consultazione bilaterale dei rettori italiani e tedeschi, magari la seconda la possiamo fare a Berlino.
No, poi sono cose che poi accadono, no? Per prossimamente verranno i 5 studi delle 2 banche centrali, no? È una cosa che Banca Centrale Tedesca Italiana è una cosa che ha funzionato, ma sai quanto tempo ci è voluto? Ci sono state delle persone con cui era impossibile, si è dovuto aspettare che fossero le cose sono venute anche dalla Repubblica. La questione è quanto tempo, quanto investimento di medio termine ci vuole per far funzionare questa cosa.
Potrebbe essere SIGN.
Poi ti capita la volta in cui c'è il ministro, il sottosegretario, eccetera, che ha di suo rapporti attivo, eccetera, e quando il vertice è convinto, allora magari quella volta va veloce. No, poi è ovvio che tutto il lavoro dietro le quinte, però c'è proprio una questione di costruzione dei rapporti.
E tu potresti essere tu la partner in via per questo? Se io spingessi un po', chiedere alla dottor.
Io dovrei essere delegata da lei. Quindi quello che potrebbe succedere è nel momento in cui lei dice
e lei
almeno
è abitato.
No, lui abita con il nostro ambiente e lei diciamo.
Ma lei come segretaria generale perde una parte del tempo?
Allora, diciamo, il segretario generale ha una partecipazione all'interno della comunità perché il segretario generale in realtà è stato in questo caso di persona che non veniva da fuori, che è diventata segretaria generale dopo aver lavorato più presentata. Lei era già a casa sua.
Come se tu tra
sì, non succederà, ma teoricamente sì, no? Cioè io ho preso
quindi va in azienda c'è il presidente, la figura onoraria.
Hanno la responsabilità, ma diciamo che a seconda delle persone c'è chi è anche più partecipa proprio nelle attività, se vuoi il consiglio direttivo, quindi ci sono stati presidenti che svolgono un ruolo formale, questi sono concretamente interessati delle attività. Sì.
Sì, no, non solo
E ogni volta l'interno collegato.
Quello c'è poco. Very good. So the bell was tossing. We are very much on time, and we start with the European excellence in digital health, with the first talk by Roland Ailes, and the second one by Vincenzo Valentini. Vincenzo was just telling that the Charité, according to the international ranking, is the first hospital in Europe. Jamel is the first hospital in Italy, so we are really in the excellence type of domain. Just a couple of words about Roland. He is a founding director of the BIH Digital Health Center of the Charité, and previously a director of the Health Data Science Unit at the Medical Faculty of Heidelberg University. And this probably is related to his previous life as founding and managing director of the Heidelberg University System Biology Center, BioQuant. And we are very much looking to your talk, Roland. Please, just an information for both. We got from our technical office the information that we don't need to carry the baby like we were doing. That distance is enough. It probably is not amplified like speaking nearby, but is enough for Zoom. But we will collect the pictures of the speakers. We will collect the pictures of the speakers with the little baby here. Yes, yeah, Twitter immediately.
Okay, I know I'm very grateful that I'm the first one not having to carry it. Yeah, so first of all, I really would like to say that I find this meeting extremely inspiring. And it's extremely inspiring because I get to know, I mean, about applications of AI, which I haven't even dreamt of. And I like the medieval stuff. I like the other part of the digital humanities. So yeah, I think by the time I'm going back home, I feel really very happy to have come here. For another reason, I'm not very happy to have come here because I was disillusionized by your comment that it's a general feature that Italian students would do their PhD and their career abroad, in particular in Germany, because I thought it was a special feature of my lab that I attract so many Italians. And I've promoted a number of, students and postdocs to the level of full professors. And I was always proud of it, just to find out that I'm just representing the average. But anyway, I'm very happy to be here. So, you see that? Yeah, thank you for this comment. Very well, very much appreciated.
Antonio, actually is 100%.
Okay, good. So in the previous presentation, I think it was stressed a couple of times that the major and arguably the most important ingredient of any kind of AI model is access to data at scale, right? And in particular in the health domain, which is very noisy, as we will see throughout my presentation, it's very important to really look at health data at scale, and I will tell you what the scale is about because it's huge. So the kind of data I'm personally involved in my research is in terms of molecular data, so genomics, genetics, proteomics, and so forth. But it also very much relies on access to population scale cohort data, at best longitudinal, because we want to predict an event much later in life. And for that, we need long observation times. And long observation times means 10, 20, 30 years of follow-up. And this data is kind of sparse. It's non-existent in Germany, but it does exist in other parts of the world, and we happily draw upon this. And last but not least, I also realized that I'm in a different, cloud here. Typically when I go to those meetings where I present, everybody has something like that on his, breast, right? And I try to look around without harassing you too much. I didn't see too many smart devices hanging around. So that kind of reminded me to keep it very simple if it comes to health data, because I appreciate that probably not many of you have been kind of confronted with that. And so, yeah, once I start with this word, that data is very important. People say, oh, come on, just another buzzword, and leave me alone. But I really would like to convince you, as the very bold title of my presentation actually claims, that in this particular respect, we really make a change to humanity. We really change the way how we treat and hopefully also cure our patients, even under very severe treatment disease conditions. So typically the kind of work I'm doing and in my community, is all community efforts. These are international efforts because it's very costly what we are doing, because you have to do it at scale. Typically, because we were asking about, price tags. The price of a typical Nature paper I write is like 5 to 10 million euros. I have to invest into this in terms of research money to get to the point. And each of those projects which you see here, and I will walk you through two of them, they are all multi-billion euro projects. And of course, evidently, not even DFKI can afford doing this by themselves, but you need like an international community which is willing and enough to bring together all their resources, all their data to actually to really come up with a data body which is actually, reflecting the diseases which you are trying to analyze. And so the first example I would like to share with you is almost an historical example, because like in 2010, many of us, in my community, cancer genomics community, stick their heads together and said, well, we want to, given that we can do genome sequencing at scale, we want to do this for each and every single cancer which is out there, with the goal, very simple, to have a catalog of genetic changes, genomic alterations, which give rise, hopefully causally rise to cancer, and based on this kind of data resources to be able to better design, better diagnose disease, but also better design therapies for these diseases. And so when we set up this kind of international effort, the goal was to have 50 different cancer types, which you distribute all around the globe. Each of these has a price tag of 20 million euros, which you had to cash in to participate into this. And so each and every single country picked its preferred kind of cancer type. And so we were sharing the load of categorizing cancer across the board. Now, Germany has a legacy of starting very late into those international endeavors. But once we do it very properly and seriously and very right, hopefully. And so I had the pleasure to lead one of those projects on early childhood brain cancers. And I was involved in the data part of 2 other German-led projects, one in malignant lymphoma and the other one in early onset prostate carcinoma. Now, of course, if you start sequencing cancer genomes at scale, you're almost doomed to find something new because nobody has looked into this. So it's more almost like, you know, an adventure into a new type of data for a very well-known disease. And then, of course, you find something new, something very important, and you write all these kind of, papers which are kind of representing what you can kind of see and what you think you can learn from that. But of course, you can go one step further and put all the data together. And we did this systematically for about almost 40 different cancer types, which have been sequenced at scale across the globe. And which we're trying to learn from the similarities, but also from the dissimilarities, the differences between the genomic alterations across different cancer types. And by doing this, and one of the co-founders of this international activity, Lincoln-Stein said, I think you rightly said, it's the largest biomedical study without having lifted a pipette. And so I was hosting one of the 5 data portals at my time in Heidelberg, which was accessed by more than 1,300 scientists across the globe, and in dozens of different projects. And of course, there was a lot of knowledge derived from this kind of exercise. But then the next question is, how do we bring this fundamental new insights into clinical practice? And so by the time when cancer genome sequencing was still very, very expensive, so in the scale of 10,000, when I started with this business, it was like 10,000 euro just for consumable costs per patient, right? We already thought that given the price decline, that in 10 years from now, it actually it was very pessimistic because 5 years later it was down to 1,000, and now it's down to a few hundreds of euros. So we can do this for each and every single cancer patient. And we actually, at my time in Heidelberg, there were 3 people, a clinician, a geneticist, and myself, and we decided to bring cancer genome sequencing to our patients. And really at scale, which means each and every single cancer patient who was treated at Heidelberg University Hospital was offered as a commodity, was offered a genome sequencing of his or her cancer genome. And we started for ethical reasons with those patients which had no further treatment options according to the clinical guidelines. So these are end-stage cancer patients where no treatment options according to clinical guidelines were available. And so I think it's very amazing. If you just look at the numbers, and I'm sorry, it's not very much, sorry. So if you just give the data to a data scientist, for 90% of the cancer patients, without even knowing anything about the clinical background, we are able to correctly diagnose and also to propose a molecular therapy for those patients. For 90%, so 9 out of 10 patients. Now the question is, how well does that work? So you have to prove that your kind of treatment recommendation is doing as good or even better than the, doctor's best choice for those individual patients. And so you have to run clinical trials. And we're doing this at scale. We are still doing this now across Germany in this NCT master program. And so just to show you the numbers from last year, we update them every year. So for a third of those patients where we offered a data-driven therapy recommendation, for a third of those cases, our recommendation by data scientists was taken up by the oncologist and were translated into a treatment. And so the question is, how are the patients doing? And just to remind you, these are end-stage cancer patients. 55% of those patients would show a disease control, which means we can keep the further progression of disease on track. 40% would show a full-fledged disease stabilization. And so we are still following those individual patients over the next years, but it's kind of reflecting the trend in the field, which is that by using these kind of methods and technologies in a very data-rich environment, that we're trying to, of course, with the help of all the other clinical disciplines, to transfer cancer for many cancer types into a more chronic rather than a fatal disease. So I just want to mention that one of this clinical trial, which is
Roland, can I ask a question on the slide before? Because I mean, it's very interesting. Just if you could say in a few sentences, what is the treatment which was suggested? You know,
it's very diverse. So if you look into, I showed you the next slide. So we have designed 7 different registry trials, which are where the patients are not sorted by disease, but by the hypothetical disease pathomechanism, which we identified by genome sequencing, right? And for each of those clinical trials, these are randomized clinical interventional trials. We sort the patients into different treatment arms, one in a randomized double-blind fashion. And so one of them will receive a doctor's best choice treatment, the other one will get a molecular treatment. So like in this example, this is a combination treatment for cancer types with DNA repair deficiencies, their pathomechanisms. And here actually, it's a machine learning based algorithm which decides based on the cancer genome sequencing data in which clinical treatment arms the patients are being sorted into. So this is based on the large foundation of data which we created in these international efforts, and this is forming the foundation for making this direct recommendation. In this case, it's a machine learning based algorithm. Yeah, sure.
How do you train this model? Because I assume that you don't have the outcome, so you can basically use a reinforcement learning. There is no reward.
Well, they are treated, and then you have the clinical follow-up. So, so you do know how they are doing a year, 2 years, 3 years, 4 years after. And I'm not sure whether I understand your question correctly, but we are comparing those patients which are treated specifically with respect to their cancer genome information compared to those which are just treated in a conventional way.
Sorry, maybe
yeah.
If you, since you said that the algorithm is choosing which,
yeah.
How do you train this model? Is it a supervised problem?
Mm-hmm. Oh, okay. So in this case, it's very simple. It's a way to understand. Well, it's called non-negative matrix factorization. So we take all the data, the genomic alteration data, we throw it into this algorithm, and it actually would produce an output which, with respect to weighted kind of prediction, which kind of disease mechanism which would be mostly affected in those individuals, and accordingly we will design the treatment regime for that. So yeah, so I think that's a success story. We changed, I mean, for many of those diseases I was involved in, we changed the way clinical guidelines are being written. We changed the way how patients are nowadays as state-of-the-art being treated. So I think it's an enormous effort which had a measurable and very convincing and successful outcome. And this is not only based on our work, of course, but by this international community. So let me switch gear in the second part of my presentation to a completely different setting of data resources which we try to capitalize on. And so in this area, it's about disease prevention. So all of you, hopefully, you're all still considerably young, hopefully not too much affected by any kind of diseases. And so it would be extremely helpful if for each of you, we could tell you for which kind of disease outcome you would be having the highest risk to develop over the next 10 or 20 years to come. So the best way to treat diseases is to prevent diseases, of course. And of course, we all know that our healthcare system will completely explode if we don't do this at scale in a better way. So it's very simple. You have a presumably homogeneous healthy population, which you sample at time point 0, and you follow them over 10, 20 years of time. You observe what kind of diseases they develop, and you try, based on the data which you collected 10 or 20 years back in time, you try to predict correctly the disease outcome which you observe as ground truth 10 to 20 years later. So we want to sort, at best, I mean, the patients or the individual citizens, healthy citizens, into different risk categories, those which are high risk, with those who are at low risk, and then everybody in between. And so, in principle, this is a mathematical kind of function which translates, I mean, given a set of predictors that can be health records, that can be molecular data, metabolomics data, whatsoever, you put this into a mathematical function. This can, of course, be represented by an AI model, and you predict something, a disease outcome later in life. Now, the problem is that for the vast majority of disease, almost for any kind of disease, these kinds of risk models do not exist. The only exception being cardiovascular disease. There are 2 or 3 well-accepted and clinically used risk models out there, but for the remainder of disease, there are none, mostly. And if you have these kind of risk models, even the cardiovascular domain, you have one single risk model for each disease. Given that we are looking at 2,000 diseases at a time, which can affect you in the future, it's kind of useless, I mean, in terms of scalability, to think about that you have to apply, to train, test, validate, and apply, 2,000 different models at a time. So at best, we have just one integrated model. So does that work? Yes, in principle, as you will see in a minute, it does, but you always have to reflect how much do you have to pay, required resources, against the benefits, right? In terms of preventive information or predictive information, which you can get out there. So, for example, the simple and the most cost-efficient predictors are 2 factors which you will see are remarkably doing well in terms of disease prevention. This is just age and sex, because the majority of diseases are simply affected as the major risk factor is aging. So aging is a bad idea. If you have access to health records from your health service system, right, like the National Health Services in the UK, producing these health records costed a lot of money, but they are sitting there because they are available almost for free, because the costs have been covered by other purposes, by payers. But then there are also very costly methods like genome sequencing and so forth, which are on the other side. So we try to come up with a predictive model which is somewhere here, up here, right? I mean, very predictive, very cost efficient, and efficient in predicting many diseases at a time. So here comes a population scale cohort into play, which I always call the largest ever single donation by a single nation to the entire international scientific community. This UK Biobank. UK decided 15 years ago to design a population scale cohort based on 500,000 individuals, which had been recruited 12 to 15 years ago. So we have a median follow-up of 12.2 years in observation time. And they decided to collect all information which is either routinely taken in the health service system, but also complemented by research-oriented data types like genome sequencing, metabolomics, and so forth. And so we were very fortunate that like 2 years ago, the first release of a data set was published, which is looking at metabolic diseases or marker for metabolic diseases. And this was a donation by a company, a Finnish company, Nightingale, which donated to UK Biobank that they would profile the metabolomics based on a single blood draw. So it's very cost efficient, costs less than 20 euros per individual, but times 500,000 is still a large number. And they published for 120,000 individuals the metabolomics profile together with 1.4 million years of patient follow-up time. So 100,000 individuals followed over about 12 years of time. And so the idea is here, and that's taken from the website of this company, what they want to do is that they want to prove the point that you take a simple blood draw at no cost at any point in your life, and you put the information which you measure quantitatively about different biomarkers, metabolites in your blood, into kind of a health app, and this will tell you what is your biggest disease or highest risk for disease for any kind of disease outcome. And so we were jumping onto this data, and of course it's always a race because everybody gets access to the data at the same time. It's a very good way to fuel competition. Because there's only one winner who is kind of heading this race, and then there are hundreds of others following up. So we always try to come first, right? So what we did is we took the data together with all the other information, we threw it into a machine learning model, and for this we tried to predict 24 diseases 10 to 15 years later, the onset of 24 different diseases 10 to 15 years later in life. And yeah, just to remind you, that's a work by a medical doctor and master student. He's our PhD, my group, Tore and Jakob, who have done this together. And so what we are doing is, so our machine learning based model would actually come up with a scalar value for each and every single disease outcome. And so we just, I mean, this scales from 1 to 0, and we build this into risk percentile. Those have a very low risk, 0%. Those have a 25% risk. These ones have 100% risk. And we compare this predicted risk against the disease incidence. So how many of those which are in the low risk, critical low risk group get this disease? Well, they should be very low if the model is right. And those who have a predicted very high risk should shoot up here because they should all develop, I mean, the best case from a model perspective, this kind of disease. So it works very well for type 2 diabetes, no surprise, because it doesn't work for type 2 diabetes, it wouldn't work for any other disease. Well, it works also for remarkably well for many other diseases, like other metabolic diseases, like liver disease, renal disease. You always see this kind of shooting up for the predicted high-risk groups. But it also works for cancer, surprisingly. The only cancer type it does not work for, I mean, it's much more noisy, as you can see. You don't see the sharp kind of clear picture. It doesn't work for breast cancer, obviously. But we don't know why, but it works kind of well for prostate cancer, renal cancer, and rectal cancer, sorry, and for some other cancer types. And we don't quite understand why this is the case. And then you can look at many other disease conditions like dementia. It works extremely well for predicting dementia in 10 to 15 years from now. It works for any kind of metabolic disease, and it works also for cardiovascular diseases perfectly well. And so then the next question is it helpful on an individual level? And yes, it is, because we can, if you just take those individuals which we think are in the low risk group, these are the greenish mark, and we want to discriminate them based on their metabolomic data from the high risk group, which are represented by this red curve. The better the spread between the red and the green is, right? I mean, the better the discriminatory power of our model is. And so, yeah, we can very well separate the high risk from the low risk individuals in type 2 diabetes, in other metabolic diseases, but also it works for dementia, it works for cardiovascular diseases like atrial fibrillation and so forth. And so I don't show this today, but I mean, we also show that you can reverse engineer this in a way that we can also explain why an individual is at a very high risk. And from this, we can actually deduce some kind of recommendation how these individuals could be potentially treated and treated or put into preventive, individualized preventive programs. So lastly, we tried to put this model to the extreme. And so we said, okay, we take the metabolic data, we can predict 24 disease outcomes at a time. So what if we just take the data which is sitting in this data resource, which is coming from the National Health Services. So this is just routine healthcare data from electronic healthcare. And we want to predict each and every single disease, which is ICD code, which is annotated out there. So more than 2,000 disease conditions at a time. And to our biggest surprise, it works extremely well. So if you look just at this plot I described to you very briefly, here you have different disease conditions, like here is cancer, blood-related disease, metabolic disease, eye diseases, respiratory diseases, germal disease, and so forth. For each of those, we actually plot the ratio between of risk incidence for those who are in the high-risk group compared to the low-risk group. So each time this hits across this 10 threshold, it means that we predict correctly those individuals with a 10-fold higher accuracy of disease onset later in time. You can see it goes up to 100 and 1,000-fold for some of those disease conditions. And again, looking at the same kind of pictures again, and we plotted this for 1,800 disease conditions, we can actually discriminate based on your electronic health record. Give me your electronic health record. I can tell you what exactly for which disease you have a very high predicted disease risk late 10 to 15 years later in life. And it works for common diseases with established risk scores like cardiovascular diseases. It works for other disease conditions where no risk scores are available, but it also works for completely unexpected disease outcome conditions. So for example, we are very, very accurate in predicting suicide attempts. And you have to think twice about it. So why should your electronic health record contain any information about the fact that you might try to commit suicide 10 to 15 years later life? If you think twice about it, it's not unreasonable, right? Because if you see more often a psychiatrist, if you are administered antidepressiva and so forth, that might be an indication for a higher risk for suicide. We don't quite fully understand each of those predictions, but we can also predict, for example, bone fractures very accurately. So we can predict for you whether you have a very highly elevated risk for bone fractures 10 to 15 years later in life. And it's kind of still puzzling, but the take-home message, and that's kind of where I would like to leave you behind and helping me with the discussing those findings and sharing ideas why it works and why it shouldn't work. I hope I could convince you that for cancer, which is always have kind of driven technology development in the clinical field for good reasons, I think it's well established that based on big data, you're actually designing, diagnosing therapies. I showed you that at population scale, we can train very potent AI-based models, which not only work in UK, I didn't show here, but we also validated this across the board in the United States, in Finland, in Holland. So it seems to be not too much biased by the healthcare system you are collecting the data from, but it kind of generalizes well to other healthcare systems and also other ethical and societal environments. And yes, I think the major, kind of powering our medical history data, which is collected routinely, is completely underdeveloped, unexplored, and it should be used at scale in any kind of healthcare system in the future. Yeah, with this, I would like to stop here. I've never worked for Facebook, but I get some funding from Chan Zuckerberg. They like my research, apparently, which I'm very grateful for, and of course, from many other institutions and companies and funding. Thank you.
Thank you very much, Moran. A very exciting talk. Also, it'll be scary, but we can go through the first questions.
Just a quick question. So I was wondering on this metabolic profile, I think you could also predict skin cancer. So do you have an idea, like if there is like a metabolic component to this, or are other risk factors much more dominant, which I would expect, but I'm not an expert.
I mean, for each of those predicted disease conditions, you really have to invest a lot of time to actually to find out why we believe, or the model believes, it can correctly predict disease outcome. And so we are using with different methods, and we are playing around with different methods for explainable AI. So here we were working with a game theoretic approach based on Shaka values, and we try to reverse engineer, so to speak, I mean, kind of the contribution of the different metabolites. Whether this is causal or just a consequence of a disease, we don't know. I mean, it's like, I mean, we are just building the foundation for, you know, centuries of research, I would say, for each of those prediction and disease outcomes. And we are far away from understanding why, for example, those models work so well for unexpected disease conditions.
Very good. Thank you. Vincenzo?
Yeah, I mean, one thing that pops up at you is that this relation of not all of them, but many of them are very non-linear. So it's very non-linear. They look like hyperbolic.
Yeah.
So one question would be why I'm a complete ignorant in this area. So that's one question. The other question is, you have all of these behaviors of the predicted morbidity in 10 years for the various illnesses. Have you perhaps ever looked at cross correlations, like illnesses that appear at the same time?
Yeah, absolutely. Yeah. So we really have, I mean, difficulties in bringing this second, I mean, kind of project, I mean, to the community, because there's a lot of disbelief. They say that cannot probably be true. I mean, you get exactly those questions. I mean, there must be some hidden correlation in this data. I mean, we looked very, very carefully into this, and because I was very skeptical when I saw this outcome, I mean, these results first place, I thought we are making a joke out of ourselves if we ever publish that, because there will be a radio oncologist said, oh, of course, that's very clear. It's so trivial that this is a good predictor for something, right? And so we did two things. Number one, we tried from a computation point of view, we tried to find correlation in the data and try to eliminate those and to see whether still the model generalizes. The second one is more like a brute force kind of approach. We actually approached physicians, specialists in their field, and gave them the medical history data and tried to find out whether it's very trivial to predict, I mean, like some kind of disease outcomes 10 to 15 years later in life. And none of this actually kind of supported the view that there are trivial correlation in there, which we are just trying kind of to unhide here.
Actually, it was not meant critically. I was just wondering whether, like, you have a high percentage of high probability to develop diabetes, let's say, and then some other profile has a high percentage of developing some other disease. I was wondering, do these perhaps correlate with each other?
Oh yeah, they do correlate, yes, of course. I mean, and in many cases, these are just consequences of early diseases. But at scale, it seems to work. And what is even more surprising, I didn't show that. I mean, this is trained on a fairly healthy, mid-age, mostly white Caucasian population in the UK. And so there's a lot of bias towards this kind of population in this UK biobank. And we brought it to all of us. All of us is a closed shop. I mean, US doesn't share this with anybody, even inside the United States. You have to find a collaboration partner who is eligible to access this data. So we work with the group at MIT. And so this all of us cohort is completely the opposite in terms of population contribution to the UK biobank. It has a very high representation of other ethnic groups, people of color and so forth. It also has a very high proportion of people who are typically underrepresented in those studies, which are like socially, under resourced population groups and so forth. And even under these very difficult conditions, it still generalizes, and we are kind of puzzled why this is the case.
Wait a second, Matteo.
Yeah, the question was, especially if there is some doubts about a certain, let's say, project, then it's particularly important to open up the data and the code used. So everybody can see the code as well.
It's open source. Everybody can redo what we have been doing. It's all transparent. All open source.
Okay, so did somebody do it? I mean, were there papers, let's say, working on double checking what you did?
I don't know. The reviewers would dislike the paper. Most recently, it didn't have the impression that they even took the effort to rerun what we were doing. They just said we don't believe, which is so
it was rejected.
Yeah, I mean, to our greatest surprise. I mean, it's yeah.
Okay.
Well, papers are getting rejected every
clearly.
Then. That's not a surprise. But in this particular case, I mean, we was in a second review round, and they have been looking at it at scale for months. Half a dozen of reviewers, and in the end, the conclusion was we don't believe it. Full stop.
And the descriptors you are using, so the input data are just blood, or did I miss something? Or
no, the second one is just electronic health
records. Health records.
I mean, like the data which is available for you wherever your healthcare system is. This is standardized routine healthcare data which is used for accounting for reimbursement purposes.
Now, Vincenzo.
I want to share something that is not, I think, so pleasant in front of the art scientists. That's since long time, doctors make their own choices because they saw that works, not understanding why. There is a very nice statement of Sir William Osler: medicine is a science of uncertainty and an art of probability. So nowadays, thanking the Roland works and some other works, we try to have more deterministic choice. So what in oncology, I am an oncologist, we have an opportunity to use for some patient what we call actionable drug or actionable mutation that have drugs that are working. But look at the number that it shows. It shows that 4.4% are advanced patients. And the benefit was in 30% of this 4.4. And it produced a complete response of the tumor disappeared in 25%. I am not a mathematician, but for 30%, 25 means that 0.4% are deterministic driven. And that is something that has to, I understand for the art scientist is really questioning, but that is the life. We use something many times that we don't know why they work, but because we trust in validation. When you are in some place where you can cure, first you cure, and then you point how I could succeed. Sorry, that is just, but of course we need to go, and that is very paradigmatic framework that fortunately in Germany is doable and not in many countries. That is true. But reality is that, and anytime, and finish, anytime that there are very few papers, very few papers that tested the capacity of prediction of doctors, 20 clinical chart where it's written everything's genomic, metabolomic, treatment, and they were requested to very eminent doctor. Do these patients survive at 2 years or not? Then they know what happened. So the capacity for these outstanding doctors, some were German, and to predict the survival of the patient was as to flip the coin, 50%. And accordingly, the probability to survive, we decide the intensity of therapy. Art, science of uncertainty, art of probability. Fortunately, we are reducing such uncertainty, but not so much.
I just want to catch up one point, which I also want to bring up in the other discussion. We all care about explainable AI, but nobody cares, for example, about explainable doctors, right?
Completely true.
So where's
completely true? Is it ethic? Sometimes I see a model that works in 80%, knowing 50% of the doctor. We are arguing the same way. Is ethic still to trust to the doctor without any AI support?
No.
That is the question.
Yeah. I mean, in this case, no, of course. I mean,
of course,
should take
validation.
Yeah,
validation
sure.
is important.
It's a good pitch for explainable physician. Okay, now Antonio, please.
Yeah, no, thank you very much, Roland. Very fascinating. Now I wonder, of course, let's assume, you know, this all works. So what can we do with it? You know, always looking from the other side, you know. So so could you give us at least, maybe I missed it also from the chart because I'm not so super familiar with the way how you depicted the data. Could you say something a little bit about the base probabilities, a priori probabilities, and what this means for the population in a sense? How many could reasonably benefit from this? Because if I just raise, if I'm on the long tail, actually, then I guess even if I have a slightly higher probability, it doesn't matter, I guess, in a way, you know. And when I get to the right, then it starts to matter, but those might be not so many, yeah. So so I wonder a little bit, you know, what would be the actionable direction in a way. I think from the work, I personally find it completely fascinating. Now the question is, you know, I bought this in the first part of your talk. I think this was pretty clear, and I think the actionables were pretty clear also and useful. Here it's a little bit more fuzzy, isn't it?
Absolutely. I mean, this is much more recent. I mean, we're talking about state-of-the-art work. So the other one has developed over 10 years. To your first question, we are very simple in terms of methodology. So we are looking at the C index. So which is kind of a measure how well you can sort your individuals with respect to the predicted risk for a certain outcome. And so I fully agree. We don't care about those on the long tail. We don't care about those in between. We want to pick out those very high risk individuals. And that's what the chart was for this 1800 conditions, where we show that we can pick out actually tens to hundreds of thousands of individuals. I mean, depending on disease conditions, which have 100-fold higher disease risk than the rest of the group, right? And so I think that makes a difference. So the question is applicability. Yeah, I'm always asked this, and I'm asking myself. So I don't know who has an Apple Watch. I mean, do you know the term chasing the rings? Have you heard that? So here are 3 rings. One indicates how often you stand up, in how many hours in the day you stand up. That's the first ring. The second ring is how many calories you spend. The third ring tells you how much time you spent moving, doing training, and so forth, right? There are millions of people who are chasing their rings. They would climb stairs, you know, at 11:30, half an hour before midnight, just to close their ring, to get the statistics right. It's so stupid. I mean, it's so easy to motivate us, right? So just imagine you had a 4th ring, which would tell you, once I wake up in the morning, I don't know, what is the first app you're looking at? I suppose emails and social apps. I would like everybody to wake up in the morning and to look at your watch, and which would indicate what exactly you should be doing today, and not on an average, but you should be doing today to minimize your risk for a disease which has a very high disease risk in the future. And if it's very specific, people would do that, because I mean, at the moment, everybody knows if I do more sports, I don't smoke, and I drink less, I will live forever, right? But I still drink, I don't do sports, and I spend too much money doing science instead of, I mean, doing sports, right?
Good
and
point.
so we need to make it very specific. And I really would like to have a fourth ring here telling you what you have to do in the morning.
What you have to do is you have to make a kind of very individual analysis. How
Yes.
much that risk contributes to the
Absolutely.
overall risk of death of an individual person.
Absolutely.
Which is very hard.
Yeah.
Depending on how often you drive the
Yeah.
car, all kind of other things.
Absolutely. Yeah. I'm not saying
Very
it's
good.
easy, but it's more like it's like a vision which I have. And, yeah.
A little bit running out of time, so I
Yeah,
said
just a quick
question and quick answers,
Yes.
right? Roberto first, and then.
I have a question about that plot that you show at the bottom right, where you, I think it was breast cancer, where you didn't seem to have correlation.
Yeah.
But it seemed to me that you had actually a negative correlation, which I've only seen once before in my life when analyzing data. And in that case, turned out to be basically a problem with data, because it seems that you were actually basically preserving the ranking and really having a very clear negative, which at the extreme, because it's always wrong. This is actually a very useful system, because you can just basically so it means that there is the data. It might just be a
so this negative
Roland.
correlation was actually suggested. We were looking at this from a statistical point of view. There's no statistical significance in this anti-correlation. So it seems to be really, I mean, noise, and what we see there might be a pattern. It might be it's because we have low numbers, we don't know, but in this data there's no anti-correlation.
Both. Yeah, I just wonder if you, in your analysis, take into account, take care of age and sex, because you said these two variables are the most important ones. And then, of course, if you have like these two groups, like the one high risk and the low risk, so I would assume that maybe in the high risk, they're all these 70 years old guys who will develop prostate cancer with almost 100% certainty. And in the other groups are maybe 30 or old men.
I have a very quick answer to this. So of course, we were very carefully looking into this. And I can tell you, it's extremely hard to beat a predictor based on age and sex only. I mean, there are thousands, I mean, zillions of studies published, even in respected journals, right? Which even didn't dare to do a benchmark against age and sex. You can all throw them into the garbage bin because, I mean, they're useless. And we actually tried very, very hard in many of those cases to beat age and sex only. I have a lot of plots about this. They're all in these papers. The first one is published, the other one is a preprint. And you will see that for many disease conditions, it's very, very hard to exceed age and sex. Yeah. It's depressive, but
so age remains the best predictor for death. I mean, that's
age and sex is difficult to change. Yeah.
Exactly. Yeah, and on this very amazing and nice conclusion, we'd like to thank Roland again. And now we pass to Vincenzo Valentini, who is full professor of radiation oncology at the University Cattolica del Sacro Cuore, with the seat here in Milano, but having a polyclinicum in Rome, which is called also Fondazione Policlinico Gemelli, where he's heading the radiology, radiation oncology department and hematology. He is also deputy scientific director of the Policlinico Universitario Gemelli IRCS and chair of AI and real-world data laboratory. He was also past president of ESTRO, which is the European Society.
May I have the first slide, please?
For radiation oncology. Now we switch the slides. to Professor Valentini. Okay. So, and okay, fill in the blank.
I want really to thank all of you for unique opportunity to be with all of you today, and I hope also some time this evening and tomorrow. First, I knowing that it's the last speech of the day, I thought that I want to act much more as a touristic guide to accompany you into unusual labs, showing some architecture. Living in Rome, I love architecture, so I will try to show you some architecture. And the second, I have really to admit that I hope in your comprehension that I'm not a data scientist and an art scientist, so a lot of AI sciences you will integrate behind that, but I will show you some architecture. First of all, anyway, I want to share the posture in this stroll that we do together, because we are in the framework of value-based medicine. Does it mean that when you are in front of what we call not communicable diseases, so cancer, heart failures, lung failures, neurological disease, Alzheimer, you are a guy that you had an earthquake in your life. Your house grew bad. You have to change your relationship, your work, your also perception of the future. You have an existential earthquake. And where are you going to? In a refugee camp that we usually call hospital. But there you have a different language. Medical doctor language is not so too easy to understand. Second, you have some time schedule that is completely different. For a Roman guy to offer dinner at 6 p.m. it's a disaster. We have dinner at 9, and that is a different. And to take some, to buy something, an exam, queue, pre-notation. So that is a refugee camp. So people is really there. And the question for the value-based medicine is, but really, what do they need? So with this value-based perspective, I want to accompany in two strange labs. One is the Gemelli Generator Lab. That is a lab where we try to take benefit from what already Roland said to you, the clinical chart and also administrative data that we have accumulated in our hospital since 25 years, because they were good. Take the address where the data were, even if they change a lot of systems. And after that, I will show you some something that happens around this kind of exploitation of clinical chart data. And the second is another lab to fill our oncology department of interactive heart, to look if we can cure patient better, to have better outcome. So Gemelli Hospital is a quite large hospital, 1,600,000 beds, sorry. We are quite one of the largest cancer centers. Last year, 54,000 cancer patients came to our hospital, even if they come many times. So 54,000 each patient, 2 million patient health service treated. And that is so a large hospital. And we collected, we have had access to more than 1 billion granular data. Granular data is glucose measurement, hemoglobin, but it's also a diagnostic report, a surgical report. With natural language processing, we can sequencing, amplify, so you can understand also with radiomic for the image, we can have how much huge oil deposit we have in our hospital. Is one hospital. And so first architecture that I want to show you. We create a pipeline where some we like to call mini bots software, you know, you are data scientists. So we're trained to go to pick up data in the data warehouse. And that means that these mini bots are tailored by data scientists and clinicians that look at what was the outcome and then tune that this mini-bot translate the data according to international coding system, creating a second level of data mart, very high qualified, where a first level of data consistency and the coding is already done by design, by the first layer of mini-bot. And then we create a second, the mini-bot is, we like to call explainable for marketing reason, but that's our trained to offer standardized outcome related to create dashboard that are sensible in the places where we are working as a clinician, clustering data in a, after elaboration, support research. We will show you some bench where we are working around. We exploit this architecture. Okay, but first of all, there is a second concept that I want to share. So this is the data warehouse that is personal stuff. We are under GDPR or the security system. And then we have these two places. As I said, it's a strange lab. It's a lab where data scientists are, I like to say them with respect with them, they are mutated guy, where they have a lobe that is engineer, data science, another is clinician. They can speak, they have connected these two lobes. Any clinician that go there find a data scientist that is trained to speak with clinician. And more we train a clinician to speak with data scientists. And we went to the department of the hospital asking for these mutant guys, doctors that exist a lot. Many times there are, we call in many Italian words that I can translate easily, that like to play with the desk. And these people work in this environment. And then we have in front of us the marketplace where we sell this kind of product. Of course, we have academic studies, pharmaceutical studies, but what is going on now is that there is a new market also in the big pharma industry, that is digital market, selling digital product. I will show you some examples quite soon. So we create in the pipeline also, so the digital products are something like that, many hubs, many different services that are selling by themselves, not related to the disease, but to themselves. And we create a company, manage property, the properties by our clinic and the university that accelerate towards the market. What are the outcomes of these services? So go on. An example. We went to the data mart for heart failure. One of the key points is not to recover again the patient after the admission in the first 30 days. That means that we can still continue to give a very high costly drug that is very efficient if you don't have the patient back to the hospital. So the cardiologists went with our data scientists and found the predictors of patient going back to a readmission. It created the model. This model was positioned in an app that we give to the patient to monitoring what is going on in the patient at home, putting the question. And this app, this model that create an alarm to the nurses that because as a delegation, this app to say something to the patient, and then as a delegation to say to the nurses, be careful that is happening something like that, and then also to go straight forward to the doctor in case that some alarm was overcome. And we did the first test, first 30 patients know that were followed. We expected 6 readmissions, looking at what happened before, no readmission. Now we are finishing a multicentric randomized, multicentric phase 2 study, but with a huge support of industry, because the industry don't want to sell only the drug, but they want to to go to the market with this digital product. So that's what it will go. So we have a robot, very nice to look if the patient fit with some trial. This robot identify in our hospital for cancer, for breast cancer patient, a very demanding trial in third line of chemotherapy, identify 99 patients in 1 month of work related to 18 months. But the clinician engaged in this trial selected in the 18 months only 1 patient. The company pay a lot of money to have 66 patients in the world. With this system in the Gemelli Hospital, we can satisfy the company by ourselves. So we engage a lot of different disciplines, and we have ongoing. So we already had 86 trials. It is in less than in 3 years, and these are the different disciplines. These are all different departments are engaged there. Some examples, some benchmark. What we do? Large database for common cancer. Why not to start to predict perioperative morbidity? We arrange the predictors of this kind of the morbidity in the first 10 days, just to predict how long the patient can stay. And so the clinic is nowadays managed with this similarity case. So the doctor, according to the surgeon, according to the collection of the individual patient major predictors, can choose the best surgical procedure to minimize the risk of toxicity. We are going in that is experimental. We are doing a perspective validation of the model to predict the perioperative morbidity according to the modulated surgical approach. So we can have dashboard that we can allow us to understand according to the drug where the markers go up and down. That's allowed to generate hypotheses of study, because we have a lot of different sequences. We are quite consistent, more than 1,300 breast cancer a year, and so we have thousands of ladies, and put in such the dashboard, we generating hypotheses for study, and we can create some database for synthetic trial. You know that FDA in America already allowed to have phase 1 study in synthetic cohort, sparing a lot of money. And that's a huge interest from many different players in Europe to manage to have such synthetic data from an hospital that guarantee quality and that guarantee a process that automatize quickly this kind of system. That was the dashboard of risk of death in the emergency room in our hospital during the COVID. We validated it perspective. It's a publication. And that is the dashboard for our intensive care, where many COVID parameters are monitored. But that is just already calculated data. So it's not something that is as look at the chart. Is already synthesized as the clinician want to have, with some calculation, some knowledge behind, already shown to the patient. That is for sepsis. So we have a pilot where we have the green light, so means that this patient has almost no risk to have sepsis when he has to put a central venous catheter. But when we have a yellow or red light, that means that we have to do special, very costly exam before, just to validate if it's doable or not, to position the CVC without any antibiotic prophylaxis. That is for tumor boards. We can read the reports, and then we can select in which side of the pelvic is cervical cancer. We have disagreement between radiology and vaginal exploration under anesthesia, and so to focus on them. And finally, this is the last bench that I want to show. We can control coherence and the quality of the internal guideline in that for cancer patients. So these are the percentage of patients that followed guideline in this colon cancer setting. And in this way, we can monitoring if there are discordance and go to the tumor board to discuss why. So I put you some example how this architecture, working clinician and data science together, so starting to the needs that we met, create some research and some deliverable that could be beneficial for the patient. And now we go to the second framework. We are perfectly in time, and that is use of the art. I want to be back there. What do they need? And more, I am more than 40 years in oncology. And I perceive clearly that on top of the quality of the treatment, when you have a refugee, a cancer patient is a patient that has a lot of fear. Fear not so much of the death, it's a fear in which way I will die, how much pain I will have. Will I remain alone? Will and then sometimes I have pain. So it's really bent to himself, looking his own neck. And so what they need is something that is, if you think, foster the trust of this page, of these people, as we had when we were born. Each of us, when we were born, 1-2 days, we can take care of ourselves. We are only crying, doing something that is just, and we are not able. So what can take care of us at that time, allowing to survive, was the gesture of welcoming at any moment of the day, cuddling. It's different if you take blood, oh, please, see, go. And then I take the blood. And finally, guiding you, because you have to go alone. So gesture is a pilot approach for this patient. But do these gestures are effective? Because given word, we have this in humans given word and actionable value. Does it mean I will go quite soon? This is nice, this study, none, almost 200 nuns. They were followed in USA for 20 years. These researchers went to this nun and asking them, may you describe your life? May you give us some letter? May you do every 2 years an MRI? And then why not to give us as a gift your brain when you will die? And they accept. After 20 years, 40 nuns had a brain of Alzheimer at MRI and at the microscope, but only 8 had symptoms. And they went to the letter, they sequenced the letter, and they found that the 32 who had no Alzheimer's symptom, even if they had an Alzheimer brain, were really using a lot of positive sentences, positive words, positive emotion, positivity. And they were quite homogeneous because they were in the same building, eating the same food, staying with the same people, managing the same liturgy. Positiveness. And we did a test. We took 104 glioblastoma patients, very bad brain tumor, that were all of them resected radically, as we can say, radically. And then we delivered them at the minimal mental test. They were still reasoning. And that is a good prognostic marker. And then we delivered them these 2 questionnaires. The questionnaire of spirituality. Spirituality is the capacity of humans to say to themselves, to the other, what is the meaning of the life. To act in the same way when they play tennis, when they are at home, or when they are at work. Have the capacity to say themselves the meaning of the life. And resilience is the capacity to be positive even in a very, very adverse event. So I think you are familiar with these curves, survival curves. We hypothesized that all 104 patients came the same day, And the more is higher the curve, higher is the survival. And you can image that these survival curves at 2 years show that we were resilient or spiritual at a test, internationally validated, have a survival like double of the other one. And no molecular test right now discriminate the survival in such a way. So actionable value, because it's up to us, could do something like that. So if the given word, so the treatment is under the art science, as we discussed before, science domain, but how can I support patient to activate positively the value? We have not to go to psychologists, psychiatrists, still stay in the framework of neopositivism. We have to offer them art. Why? Because art activates in humans the two major dimensions, freedom and creativeness. If we expose them to freedom, because I can interpret from some message from a painting that is completely different from the other one. So by design to create a lab where art is part of the cure. So our treatment room are in the Arena Colosseum. Why not? Are for the children have a story. We tell them that they are going into a submarine to play as Captain Nemo. We reduce sedation, anesthesia. The Italian movie, The Life is Beauty. Yes, and they are so happy, these children. They offer us something that is the most rewarding event that we have. They came back at the end of the story. We are the radiotherapy center of the Children's Hospital, the Pope Children's Hospital. We treat every day 10, 12 children. And that means that to have them back is really great. And then we went in the places where we do chemo, where the patients stay 2-3 hours in the chairs waiting for vomiting or something like that. We put nature, we put painting of frescoes, and we went to the major museum. Vatican Museum gave us 140 images, so you can see Sistine Chapel much better there than in the Sistine Chapel in the reality. We expose by design the patient to art. And last but not least, all this stuff is done by donation. 11 years ago, I went to the Boston Hospital and say, I want to do gemelli art. But please, not give me any money. It's not a marketing process. It has to be a gift for people. And the real common people follow us. We collect 100,000 euros for such a project. And you can receive chemo choosing where? In a garden, in the Dolomite Mountains, into the beach, to the Sistine Chapel, to see movie. And sometimes we have issue with the patient that want to stay still in the chair, even if the chemo is finished. And what is for me a lot of rewarding, I have this child that has to stay, to have 2 treatments in 1 day. And so 5 hours in the hospital, how we can manage it? The staff went to the cartoon agency in Rome, asked for having cartoon, the staff, without informing me. I got it by the internal chat that said, we managed this guy in this way, we call the internal chat good practice. And then I saw that immediately, so it's part of the work. And finally, when you are in the chair, you have this dashboard where the major artistic channels are connected with the major dimensions that are in trouble during a cancer journey. And when you push one of this cell, you have what we call the seeds of beauty. So no artist want to be outside this game. All of them will go and the musicists, poetry, any people want to be there. And when the patient can stay with the chair, listening, so this is a quite nice piano player, very famous at the Metropolitan of New York. Every year he has his own rose season. He gave us 20 concerts that we cut in the different and the patient stay in the chair choosing something like that. On the basement of this platform, we put some AI that are the same services in some way for profiling as Amazon with this game I'm doing, just to understand the preferences. Then we do some sentiment analysis, and we want to arrive exactly inside the, of course, we creating with our data scientists some models behind them. Sentiment analysis one way, of course. I hope that you will have some other suggestions to offer us to manage better this kind of framework, because the final idea is to arrive to the patient to say, you need some drug for your, some cardiological drug, some diuretic drug, and let me say, three Mozart concerts. Why not? And that is not only in Gemelli, our network in the Campobasso, we have all the same approach with the patient. That is in Puglia, close to Bari. This is in Sardinia, Materhart. And finally, in the Tiber Island, we have a Roman temple. We are creating a new set that is using 360 technology. You can choose where you do treatment, but when you go close to the screen, use like a wheel. Probably no, 360 is a technology that you are in a sphere of the environment. The more you go closer to the screen, largest you see as a window, and the patient can choose there. So I'm finished saying that as we know, science is that we hope to have more and more precision medicine, even it's still a lot under uncertainty environment. But by design, we have to put some really perspective approach that consider actionable value, because there's tremendous impact, and that is the real personalized medicine. So I am delighted that I'm sticking to my 30 minutes to have this kind of heuristic tool to see two architecture, one for big data in the real world data, and one after use in the radiotherapy. Thank you.
Very well. Thank you. Thank you, Vincenzo, for showing how Gemelli is using their own data and this new form of therapy, which are very much of interest.
No, thank you very much for this presentation. I made a photograph already at the beginning of your presentation because of the Sistine Chapel image in the waiting room, because actually I'm working on, I have a project starting on the 1st of January about art and architecture in the hospital in the early modern period, in my period, which I'm studying, but I'm interested in seeing all this project today. And you can add another one at the Bergamo. There is one, another project between the Accademia Carrara in Bergamo and the hospital in Bergamo now. I will tell you later, but they use the same sort of material from the museum, the local museum in Bergamo, to make less terrible, especially the waiting rooms, because of course, probably art cannot cure, but can help, as you have said. And I think it's quite interesting for me, your presentation, and maybe we can talk about that more, because of course, in the past, the hospitals were very beautiful, and that's very interesting. We have so many hospitals. There was no medicine like today, but there were a lot of fantastic hospitals that were decorated with frescoes, etc. And it was not just a matter of patronage, it was also because something...
I completely agree. I know there are many hospitals use art and nature there. What is something that sometimes is considered an addition? No, it's part of the treatment. We need to create framework that measure it. As Roland said, many things, gender and age, sometimes it's not measured, put in the system. And sometimes the machine learning system or the deep learning system will show you how important it is. We managed a study in 2001 where we tested how many glass of wine you drink during a breast cancer treatment, adjuvant radiotherapy. And the lady would drink 1 glass of red wine, had less toxicity in the skin. Mm-hmm. But we don't measure the glass of wine that you drink usually during treatment. We have it has to be Italian wine, of course.
Other questions? Yeah, please, Antonio.
Vincenzo, thank you very much. So I think this opens up this general question of non-biomarkers in general. I think on the one side, yeah, where you use kind of behavioral markers to as part actually of the diagnosis, and then use non-medical interventions in general as part of the therapy. Yeah. So kind of extending this realm of the medical bubble, you know, to kind of a more extensive real world kind of environment. Yeah.
But as today, we enjoy to be interconnected, even if we have different domains. We call Vivomic the study of behavior. We start to sequencing it because Vivomic is coming up. And we know that, for example, there are data that putting in correlation the time that the patient are in the social and the toxicity of chemotherapy. More the patient are in the social during chemotherapy courses, less toxicity they have. That is Vivomic. But we have to be open in the mind, start to measure it.
Yeah, absolutely. And also similar to what Roland has shown to us, we need longitudinal data also for that. And this is at the moment why we have some actually, fortunately, for the biomarker, you know, in the biosphere, so to speak, we are still lacking it actually in the behavioral domain. And I think this is pretty relevant actually to build this up and be able to tap into this and then combine it actually. Yeah.
May you push them.
We have so much discussions about data usage and the way we are allowed to use it with our ethics and regulatory committees. It's very difficult to convince them, but just saying it's almost mandatory to make use of all the data which is out there, because otherwise you're neglecting a certain chance and truth to be used for in particular in the medical field. So yeah, it's a long ongoing struggle and fight against people involved in data security mostly, mostly in data security, not so much in data safety, data protection. But I love that. I mean, it's beautiful. I had one question. I mean, so you showed the Kaplan-Meier curve, right? I mean, you had like two parameters, spirality and
resilience.
Resilience. I wonder how you quantify that or you categorize that, because I reckon that it really depends on the way how you categorize that you have a rather large or more narrow
we qualify as a spiritual and resilience, as in the literature has been done, patients who are in the upper quartile. Because it's one test is 18 questions, and the other one is, so this test is validated internationally, so there is a weight for each answer, and then you have a number, and then you put this patient in.
So that's like international. So that's an international.
Yes, that's are two international validated test, FACIT, and blah blah.
Yeah, sure.
And so they are internationally validated.
Yeah.
I tried to go too fast, probably, sorry, but I don't want to stick over the time.
One very quick question. I very much like your approach, but I wonder if it is like commonly accepted among your colleagues, or are there some also medical doctors who say it's maybe waste of resources or waste of time, or is it like commonly accepted? And if so, how do you deal with this kind of criticism?
Yeah, that is something that is unbelievable accepted, because quite offered an environment where the patients are less demanding. So at the bottom of the line, doctors and nurses have more time to do their work, because when you are in a refugee camp, and don't care of your patient or the needs of the patient because you don't cuddle them. And that means that you have really stressed people that don't listen you. They want to say, I am fair, and you don't care me. So that is why I said gesture, because all people that are right there as the typical displacement, they think to go into the hospital, dark environment, and then say, wow, where am I, sorry. And then having such a displacement, they perceive that as a gesture of attention to them. And they quiet, and you save time.
I would be, first of all, I love it. But the part about, for example, art, in some way, it's a passive way of, engaging with people. I would be very curious if having some type of active engagement instead would be potentially more effective. And this could be from, actually have people, I don't know, drawing art, all the way to doing something like, having ChatGPT and being able to talk with ChatGPT and ChatGPT answering back to you. It might really be a way for people to feel heard.
Okay, of course, there are two dimensions. First dimension is you have to consider that we manage all this stuff not as the highest priority or the middle priority of the hospital. It's only because we got the donation and we trusted in this 11 years, we arrived to have such an architecture. So that means that from a scientific point of view, we start to, first of all, to make observation how the exposure to art create, as mentioned, new sentiment analysis. So because namely it's the delta, what is at the beginning, and then we try to phenotype them because actually we want to arrive to prescribe art exposure. Second, to go to the second part, why not to offer them laboratory of creativeness? We do something with aesthetic, so for the ladies who have namely breast lady who have to recover their own image, we do some lab with making hair or making I don't know the English names when the dressage, so for the eye, sorry, the makeup, something that is also art. And then we want to have some, but that's required more money. We are looking for it. That is the third phase. First is phenotyping. Second, we start to have some pilot for. Unfortunately, that we are not alone. We are attending to reclaim for a Curie program with 7 hospitals in Europe. We have already some commission from hospitals in North Europe that they want to replicate this program by design. So we are growing. More we will grow, more we will have money, and more we will do, absolutely. Because freedom and creativeness is really a sign to be humans from my point of view.
Very good. Roberto, you have a follow-up question?
No.
Well, as somebody who was seriously in the hospital for this close to actually not being here today, I actually agree that it's really important. I think that the human touch is, it's really important.
I stay in the hospital for 3 months in a wheelchair because I had a ski accident, and I was surprised that I could detect who will have helped me to go into an elevator or we will not. 10 meters before going there, because the posture of these people to avoid my eye was so easy, because when you are sick, you return like a child. Because we grew because someone took care of us when we were nothing. And when you have something that scroll your glasses by some dust, and the existential earthquake show you what is so relevant in human relationship. So to take care. So the polarity of the vector, are you thinking to yourself or to the other one? And that's is really, really there, very, very tangible.
Very good. Oh, yeah, please. You have a question?
It's a curiosity. I mean, this is amazing, and I think that it's also reshapes the way we should look at hospital, like with a very potential also. I mean, for us, like this also opens for deductive issues and things like that. I was wondering whether did you say that in that kind of environment, people are also more compliant with the therapy they have to follow, like they become more treatable also in a, like they let you do what you really have to do and stuff like that. It means like a more comfortable environment create a better patient, even
but also
for
better nurses.
Yes.
So before doing that, nurses, when I go to the visit for the ward, the nurses don't say me hello at all. Now, if I go there, since 10 meters, oh, professor, hello. And that's positivity for the patient. Engage them, create trust with the staff, because positiveness in the environment is easy to understand. If you have two nurses that are fighting each other, the dark cloud is in all the beds of that part of the world.
Very good. I think.
Yeah, I'm just wondering, in the situation where there are less and less doctors, at least in Europe, and personnel staff, again, coming to the price tag, what does it cost to include such solutions in the hospitals, and establishing it as an important stream that needs to be researched and implemented along with the more accepted scientific
It's really related to what means value. Because, for example, hygiene, to clean the hands, so to take care of hygiene in the hospital is a huge cost. But because you have that risk so high, if you don't take care of that, the health system provide to put all the tools in your world according, because that is something that provide value. If we will arrive to show that I can cure more patients with this kind of system, I can put the quality, so a value that can be put in the numbers to have some evaluation, and that's will try to have a good position. Now we are really we are breaking the ice that is considering everything positivistically, science-based, with not putting at work value. And that is something that, of course, will require some pilot studies and pilot center, and then we will see. If you create a real value, then it will be possible to put in the organization.
I think we make a compliment to medicine when we say that medicine is not a science, but medicine is an art. Because who knows really what is art? Art is mastering some technology, but with a level of creativity and freedom. And yeah, we have seen in this session, going from the biomedical data to some software data. We should not forget that placebo is also therapy when it works. So, and how complex is to collect all this information, make sense of them, and how great there are some people pushing also in this direction. So let's make a big applause to the speakers of this session. And I would like to disclose with you a little bit of a personal information about Vincenzo. Today is having a round birthday. So I think it's a good occasion to make a big happy birthday. Yeah. Well, we can disclose that he's not 30 and he's not 40, but he's around, okay? That's good. Very good. So it was an amazing day. And tomorrow is moving on with the large language models and the chatbot in the museum at 9 o'clock here again, and with the same spirit. And again, a big thank to Villa Vigoni for hosting us, and Francesca for having initiated all this. Yeah, thank you. So at 9, oh, we have really 1 hour freedom. At 7:30, the dinner will be, supper will be served in the same place.
Just remember, tomorrow we are starting at 9 because we anticipate everything to have lunch at 12:30.